Fall 2021 Faculty Forum. It's November already, so the forum has been going on for very smoothly. I'm happy to report for the semester. So just a few housekeeping items. We are recording this session so that we can share this presentation with a wider array of folks on and perhaps off campus. We have hopefully other attendees joining us virtually apart from the live attendees here. So if the virtual attendees would like to ask questions, there are two ways. You can send an email to ORSP. The email address is orsp@uwec.edu, or you can text your question to the following number, 715-226-4969. So two ways for the virtual attendees to submit questions to our presenter. And of course, the folks who are joining us here are welcome and encouraged to interact with our presenter through asking questions and discussions. So without further ado, I'd like to introduce our speaker for the day. And that's, of course, Dr. Rashid Dave.
Dave, should be fine.
Okay, so Dr. Dave is an assistant professor in computer science department at the University of Wisconsin-Eau Claire, of course, campus here. He has earned his PhD in computer science with machine learning major from North Carolina A&T State University. He is the director of artificial intelligence, machine learning, and security, sometimes abbreviated as AIMS, A-I-M-S, research group in computer science department on campus. So thank you, and the forum is yours.
Yep. Thank you so much, Catherine, for the warm welcome. Good afternoon, everyone. As she said, myself, Dr. Dave, you can call me Rashid or Dr. Dave, anything is fine. Today I'm going to present about one of my research projects. There are almost like 13 projects going on in my research group, but I just wanted to talk about one of the fascinating one. The title is Continuous Authentication Using Mouse Dynamics Depending on Machine Learning and Deep Learning. I'm going to talk about the problem statements of this research project, the agenda of the motivation of this research project, what were the objectives that we selected when we started working on this research project, hypothesis of this project. Also, I wanted to share and discuss about how we collected the data for this project, what research methodologies we approached towards to, and how we evaluated the experimented results for this. Especially the important thing was to give a good contribution or a novel thing to the field outside of computer science. I would be discussing that too in later on slides. Let's start with the problem statement. Right now, I just want to give you some multiple examples so you can understand what the topic is about. I'll start giving an example. Catherine, you use a cell phone, an Apple or Android?
Apple.
An Apple? Which version, if you don't mind me asking that?
A very old version.
All right, I can give an example. I'm just happy because I just got a gift from my wife, and that's 13 Pro. That's a new version. And I was used to use iPhone 7 Plus. So in the older versions of iPhones, even if you go in the Androids, you can just compare both of those. Either you can give your fingerprints, right? Or you give the passcodes or the pattern, right, to log in your cell phones. In the new cell phones, you can do either iris or the face recognitions, right? That's the first version of doing all the login systems in the cell phones. Let's talk about the banking system. Ben, how would you log in your banking system?
Username, password, and then two-factor authentication.
Username and password and two-factor authentication, right? Imagine if I know all of that.
Yeah, that'd be nice.
Exactly, right? Let's talk about our UWEC UW system authentication, right? How many of you are already facing that problem? Oh, each time I have to log in through Duo. Why is it happening, right? All of us. But after this talk today, you'll be thanking Duo that, no, this is perfect that at least Duo is there to make sure. But imagine if I have, Diana, your cell phone with me, right? And I know your credentials. Can I log into your system? I can change your leaves. I can see what pay scale is yours. I can see your personal information and everything, right? How would I make sure? Another last example that I want to go with, many robocalls that comes to us, right? And some people do pick up, and they're like, hey, congratulations, you got a lottery of $1,000 for Walmart, right? And you just have to do this, this, this. There will be an OTP sent to your cell phone. And once the OTP or that number comes to your cell phone, make sure you tell us, right? So we can give you the authentication that this is how you would get the money, right? Most of the people do not do that because they know it's a robocall. But some people, in excitement of getting $1,000, especially in COVID, they'll be like, yes, it's an opportunity to get it, right? Once you give the OTP, what happens? Sir? If you give the OTP, what happens?
I don't know what OTP is.
An OTP is a number that's sent by either a banking system or credit card system or the system to authenticate you that yes, that's you or that's your login credential. So that's sent to your cell phone.
I don't go online much of it.
That's luckier, that's perfect. But I believe most of the systems that do send OTPs when they want to make sure that, yep, this is you, right? If you give that OTP to the person, especially in India it happens, basically from where I am from, right? My dad used to get a lot of calls of it. So when you give that OTP, the person can use that OTP to authenticate himself or herself being an imposter, which is not an actual person that you should have it, right? If they can have that, they can transfer all the money of your savings and checking accounts and all your loans to theirs, having just an OTP. Which means all of these examples I wanted to share because I believe when we started working on this project, there are no solutions available to authenticate a user once a user has completed the login, right? Once the user is authenticated as a static system. Either it may be going for patterns, it may be going for the username and passwords, CAPTCHA, going for the face recognition, iris recognition, fingerprints, many more, right? So depending on that, we went to the motivation that having no mechanisms that uses continuous authentication of a user after the user has been logged into the system, right? So the motivation behind that was each user has a different behavior of pattern, how they're using the system, right? I would be using Canvas differently, Ben would be using Canvas differently. Each one of us use each systems differently. So depending on the behavior of the user, we can authenticate them. And there is also nothing to remember like your username and password, having the files of, oh, I forgot what was the username for this one, what was the password. And we keep ending up getting the emails, reset the password, right? For this one, it's easier. The objective of this research, especially for this project, was to build a system which continuously authenticate the user depending on their behavior. Also, just not that, to make sure that whoever is logging in the system or whoever is using the system is the legit user. With that, the system should also be able to detect the imposter, or I would say a negative person or a person shouldn't have the credentials or shouldn't have the access to the system, right? And once the system detects that, yes, this is not me, it's someone else, or this is not the user, system should be able to lock until the actual user uses the credentials back. We had 3 hypotheses working on this project. The third hypothesis is currently ongoing. The first 2, we have achieved that successfully. I'll be talking about that in the next slides. The first hypothesis was when it comes to user behavior, like user pattern behavior for any system, for anything, machine learning solutions works the best for the security of data and privacy, especially comparing it to the conventional methods of the static methods. And the second hypothesis was to avoid the information breach, right? Especially we do not want the person who shouldn't be allowed to use the system, right? To avoid the information breach, our proposed system will be able to detect the imposter, even though if the imposter does have the credentials of the user. And the third hypothesis, which we're working on right now, is of deep learning. When it comes to deep learning, I believe it gives even better results. To the best of my knowledge, it has given. So deep learning gives even better results to authenticate a user based on users' behavior of pattern compared to machine learning. Just want to talk about 2 quick existing literature which was used to work on our research project. The first was for intrusion detection for mouse movements to go for imposter detection. So they used a methodology called random forest. It's one of the famous machine learning algorithm. And they used a data set to work to find out whether there is imposter detection or not, or there is a negative person who shouldn't be allowed or not, right? They used a Balabit data set. The data set was publicly available after 2016. It is the only one of the important and strongest mouse dynamics data set, right, which has certain amount of mouse events in it. They chose a smaller set of 10 users, and they developed their own model to figure out the detection, and they got the average accuracy of 80%. So I believe their model did work good, but working with machine learning or deep learning, 80% is not something what we expect. So we went for the next one. It is similar to our project that what we are working on, but they had limitations that we are overcoming with. So they developed their own data set using into some constrained environment. They developed their tool to get the data by working with the people over there. I don't think so they had just students, but they had a lot of people going for the data collection process. But they just focused on two important things of mouse: mouse move and mouse click. Each person had almost like 50 sessions, and each session of was 30 minutes. I believe they had 28 subjects, which means they had 28 people in together. And the average accuracy they got from their research or from their project was 87.26%. Before I go for the data set collection and everything, I want to give a brief information just in quick way that what this project is about. After all of this, you can understand, to complete the continuous authentication, we chose mouse. I know, mouse is not the only thing that we all use, but most of us, we do use mouse when we're working with our systems, right? How I am using mouse is different than how Catherine uses mouse, right? So we chose the mouse dynamics, different actions of mouse to authenticate a user continuously. To do that, for our research, we collected our own data. Now, my research team and I, we worked together to develop a Python program which ran in the background of our system to collect the data set. How we collect the data, anonymously we send the emails to College of Arts and Sciences to the students and faculties, and obviously we were approved by the IRB and then we did it. But we had students and faculties coming to our computer lab of computer science department, and they were asked to play a Minecraft game. I believe you all have heard about that, right? That's a famous game. Even I didn't know about that either, but it's a famous game over here in States, that's what I believe. So they played the Minecraft game for 20 minutes, and based on their session, our program developed by my research team, right, it collected the data for each of them. Now in the data, you can see in the last paragraph, we had certain fields in a row. We had the time, we had the X and Y, button pressed, and the subject ID. I want to go in detail of that. So the time is the time when the session is recorded. It's a Unix time. X and Y are the coordinates when you have your mouse on the screen, right? How your mouse is moving, it would give the coordinates of X and Y over there. And also the button press, it has, I believe, 6 events. I'll be talking in the next slide. There you go. So on the left corner, you can clearly see that we have a sample of 7 users. I forgot to say one thing. In our data collection process, we had almost 40 users who came to play that Minecraft game, and we had 40 users for the data collection process for our first phase. So that's one of the data set of user 7 you can see. It's just a sample of like 10 data points of that user. You can see first is the timestamp, which is showing the time. Now it's showing the seconds in the millions because we have the timestamp of Unix. We started in 1970. Also, you can see you have X and Y axis that gives the location of the mouse, right? You have the button pressed. Now, -1. So there are different 6 events that we are focusing on. -1 shows mouse is just moving. 0 shows mouse has a left click. 1 shows mouse has a right click. 2 shows it's releasing the left click. 3 shows it's releasing the right click. 4 shows mouse scrolling up, and 5 shows mouse scrolling down. So these are the separate events that we're focusing on. And that number, especially for the button pressed, shows that. The subject ID over here shows which number or which user it was, just to give an ID to the subject. On the right corner, the graph shows how people played the Minecraft game in total of the session of 20 minutes, right? How they were playing game. This is an overall scenario of user 7, user 9, and user 12, that how they use their mouse for the 20 minute of session. Yes?
I have a couple questions. Was it survival or creative mode Minecraft?
It was survival. Yep.
And how would using Z coordinates, I know Minecraft has those as well, how would that impact data? Would that be a useful thing to collect at all, or no?
So the question is about how it would impact the data that's collected by Minecraft. I want to go for like, we only collected the data anonymously how a person is using for the mouse. So there was nothing to deal with the Minecraft itself. It was just the mouse. So it wasn't Minecraft. The current project that we're working on, we have like Piano Tiles, Ninja Fruits, Snake.io, all of that games. The only focus of ours is the movements or the events that's happening using mouse. So whatever happens in the Minecraft, that's fine. All right. You can see at the bottom over here, based on our data collected, we extracted 39 features. I'll be talking about that in the next slide. Before we go with that, we have divided our segments, I believe, the mouse movement segments, right, into 10. You can have 15, 20, depending on the size of your data set. But before we go ahead with the data extraction, the first thing or important thing to do is machine learning is to remove the duplicate data or to remove the data which has empty fields. Because if you do not do that, there are higher chances of overfitting. That means your model might give you like 100% full time for the first time training, right? Which is overfitting or your model is biased. So to reduce that, you should remove the duplicate data, or you should remove the empty cells. That's what we did. You can see there are 39 features that we have extracted from our data set. I'll be talking about each of them in detail. The first one, v of x, is the velocity of the x-axis, right? We saw that in this slide that we have x and y data points, right? X and y data points from the mouse, how it's moving on the screen. So we have velocity of x, then we have velocity of y, and v gives the vector of velocity of x and y together. A is for accelerator. So if you move your mouse quickly to right, quickly to left, anywhere, right? So how quickly you are moving your mouse, that value is for, accelerator. Jerk. That means if you're using your mouse and you're quickly moving and quickly not moving back, that means your speed is decreasing, right? So you want to make sure that how quickly you're moving your mouse and how quickly you're decreasing it. So the difference of increasing the speed and decreasing the speed that gives you by the jerk. The tangent. Tangent in the sense of if you have a mouse, you're not going to move it with like 90% or 45% or 0%, right? Your mouse will be moving in any direction it wants to. So from that, it collects the tangent, or I would say the number of the theta. Let's go for an easier one, the math one. The corner, like it's 45% or 30%. That's given by the tangent. Curve. If you use a mouse, right? Your mouse, that might be, you might be going for straight, you might be going as a round, right? So you're not always going straight using your mouse. So C gives the curvature in the sense of the curve or the mouse, how you have moved your mouse. The type, we are focusing on 3 movements of the mouse over here. MM stands for mouse movement. PC stands for press and click. And DD stands for drag and drop. Time elapsed. So this time is between this 10 segmentation, that how long it took to complete the segmentation of 10 data points. Then we have the trajectory length. Trajectory length is the length of your curvature. What was the maximum length of your curvature? Then you have the distance end to end, which means it's starting from your main. If you started the session, your first session started over here at this point, right? What was the end point and the distance between that? That gives you the distance of end to end. Also direction. So for the direction, if you're using a mouse pad, right? We divided the mouse pad into section of 8 parts separately, going from 180 degrees, 30 degrees each of that, right? Going for it. And dividing in the 8 parts, we figured out in which direction your mouse is into. Then you have straightness. Straightness is the average of giving for the curvature and the straighted line. Number points. Number points are the total data points of the x and y, right? Moving your mouse on the screen. Then you have sum of angles. That means your mouse be moving in different angles, right? In the 20 sessions. So all of the summation of that angles where your mouse has moved. Largest deviation, which means it is the largest deviation or the largest distance of your from your starting point till the ending point. So it might be possible if you imagine that this is your chart, right? And you're using your mouse throughout the session over here. But for one session or for 1 second, you use mouse from here to here, right? Outside of that. So that should be your largest derivation. And We have sharp angles. Sharp angles is something when you're using your mouse, we have a threshold of 0.05, right? And if your angle goes less than 0 to 0.5, it goes into the sharp angles, and we have a back time. A back time is something that relates to accelerator. As I said, how quickly you move your mouse, right? Or how quickly you increase moving your mouse, right? All those timings are called the back time. So I believe these are the 39 features total that we extract from how you play the Minecraft game, right, that we have extracted. This is the basic architecture that we have used for our project. So you can clearly see from the screen over here that the first thing was the 40 users to collect the data, right, playing the Minecraft game. Then we pre-processed it. I did talk about that in the previous slide, right? We pre-processed it, going to normalize it, and then we eliminated the duplicate data, and then we extracted the features from it. After that, we have 3 versions going over here. People who doesn't know machine learning, let's talk about that. When you go for a machine learning model, you want to give some amount of data to train your model, to recognize something that, yes, this is what you have to predict, right? And some amount of data to test that, okay, you used 60% of data to train it that this is you have to predict, right? And you're using 40% of data to test that whatever you are trained for, are you able to predict it or not, right? Similarly over here, for the desktop train, validation, and testing, we used for the training and validation 70% of our data, and we used 30% data for the testing. You can see over here for the normalization, I've written optional over there because we are not using all similar machine learning algorithms. Some of them do require normalization. That means you have to normalize the data to interpret it by the classifier algorithms, and some of them are not required by that. But in general, I'll go for that. Once the data is trained, it will be fed to the model over here, right? And it will be trained over here. After training, you would want to test it, that whether your model or the machine learning model is able to detect the actual user or the imposter user or not, right? And you get the accuracy of that, that yes, I believe out of 10, 7 times the model was able to detect that yes, it's banned, right? And 3 times it wasn't. We have a threshold for that until the model reaches at least 8 times out of 10 that yes, it was banned, it will go back to the model to train it again, and it will test it. So we have a threshold of 80%, right? And I believe most of our models are doing better than that. The machine learning models that we have used in this problem, for now, to the best of my knowledge and my team's knowledge, I believe random forest, decision tree, and k-nearest neighbor, these 3 are the name of the machine learning algorithms which have worked best till now to predict, to detect, and to authenticate based on users' usage, behavior, and patterns. So that's why we have used these 3 algorithms to work on that. Scikit-learn software is used to analyze the data of that mouse movement and clicks, right? I talked about all the features of that. And a significant step for the classifier was to convert the data into CSV file. If any of you are working with machine learning or AI, you would need to know that you have to convert your data into the type of file which your classifiers or the algorithms can interpret. So for this classifiers, we converted into the CSV file so that the algorithms for our models can interpret it easily. These are some phases I want to talk about that's detailed in our model, that what we have worked on for our project. The first was the data preparation phase, right? You can all see that. I talked about that. We collected data, and we made sure the data is in good shape. Then the data set filtering. You would remove the duplicate rows and remove the data fields. That's empty. Feature extraction. We did talk about that. 39 features that we extracted. User behavior classification phase. It's over here that you can see. Your mouse behavior collected. Then data collection, data cleaning, then you go for data selection, right? Extraction. From that, whatever your data is generated in the CSV file after extracted, you would fit it into the model, right? In the model, you have 3 separate machine learning algorithms. You go for decision tree either, or KNN, or random forest, right? We would provide 70% of the data to all of these algorithms to train the model, right? And then you would use the 30% of the data to test it. How to test it? To make sure that whatever data is fed to the model, it is predicting the actual user, and it is able to detect the imposter from it, right? We have several, I would say, definitions for precision, recall, FN score, and accuracy. These are the terms used in machine learning when you want to evaluate the performance of your model. So we are using accuracy, precision, recall, and FN score. I'll be talking about all 4 of these in the next few slides so you'll understand what they actually mean. And this is the terms that's used for evaluation of your model. I'll talk about all of that. So the results. I know it's a little bit hard to remember, and it's a little bit like you might not know about machine learning in detail. That's why I also have some definitions over here to make sure that you understand that. So the experiment results, we had 3 separate phases or stages, I would say. The first is verification stage. To verify, you want to make sure that whatever input you're giving to your model or whatever inputs that your model is being trained on, it's perfect, right? So all 3 classifiers in the sense of the algorithms we used, right, decision tree, KNN, and random forest, were only contained the genuine or the actual user's action. We trained the model based on the actual user's action. Then the experiment was conducted for training and testing separately for all 3 classifiers. This model were tested. When it comes for the testing, how we tested, we chose 50% data of the actual user and 50% data of the imposters. Now, there were no actual imposters because, as an example, if I'm testing Ben's data as imposter, I would have my, Diana's, Catherine's, and many more people's data to make sure that the system is able to detect the rest of the people are imposters and Ben is the actual user. The second is authentication stage. For authentication, you can imagine that all of our project is about finding 2 people, right? Whether it's a true person or an imposter, right? A negative one. So the imposter actions were selected from the other users. I just gave an example of that. We wanted to make sure it's Ben, and we would feed other people's data to show that, okay, these other people are imposter, and Ben is the actual user. Now, there are 2 scenarios based on which we did our testing. So we trained the machine learning model from one user's mouse movement data, and we tested it on the same data, right, dividing into the 70-30 ratio. And the second scenario, we trained all users' data, and we tested from the all users' data. So we did the scenario of 1-to-1 and many-to-many, with training of 70% and testing of 30%. So evaluation definitions: precision, recall, F1 score, and accuracy. Precision is the ratio of correctly predicted observations in the sense of correct users, right, to total correctly predicted users for our project. The recall is the ratio of correctly predicted users to all the users available into the class. F1 score is the average of precision and recall, and accuracy is the total number of predictions, doesn't matter right or wrong, but total number of predictions to the available number of users into the data set. This is the first scenario where we have talked about like one user was trained on the same data set and tested on the same data set. So this is for one user. You can clearly see that on the table. Left hand side, we chose randomly 10 users. User 35, 7, 9, 12, 15, 16, 20, 21, 23, and 29. These are the 10 users we selected randomly to run our model for 1-to-1. And we had decision tree, k-nearest neighbor, and random forest over here, right? All of these fields shows the results for precision, recall, F1 score, accuracy, and AUC. I did talk about this 4 of this. AUC is area under curve. That's the full form of that. And what it shows the performance of a model, which means in machine learning, higher AUC, that means your model is performing the better. I know these numbers are confusing, so let's go for the highlighted one. You can see the accuracy is the most important one because accuracy shows how your model is performing, right? From this, you can clearly see that decision tree had accuracy of 91.9%, k-nearest neighbor had the accuracy of 94.4%, and random forest had accuracy of 79.7%. From this, we can clearly see that the DD, KNN, and random forest, among 3 of those, the second one, that is KNN, worked the best for this scenario, giving 94.4 accuracy, right? If you can recall from the literature, the first paper got accuracy of 80% and second one got 87%. You can clearly see that we had better accuracy than them. The highest average accuracies we achieved for this scenario was from user 9. You can see 96.2, 99.2, and 80.1 for the random forest. And the lowest average accuracy that we achieved was from user 12, going for 90.1, 91.5, and 75.2 for decision tree, KNN, and random forest. That was the first scenario, training one user and testing on the same data set. Now we have training all users on the data set and testing all users on the data set, right? You all know about now precision recall, F1 score accuracy, and AUC curves, right? So I'll just directly jump to the accuracies over here. You can see the average accuracy we got for this scenario. For decision tree is 95%. For k nearest neighbor, it's 99.3. So it's almost, you can say, 100, right? Just a little bit less, but it's almost 99.3. And AUC, you can see area under curve is 99.9. That means your model is really performing very well. And for random forest, it's 89.9. So you can clearly see also in this scenario, KNN, k nearest neighbor, one of the algorithms performed better compared to other two algorithms to predict the actual user and to detect the imposter. Evaluation. Again, some terminologies of machine learning, FAR, FRR, and EER. So FAR stands for false acceptance rate, right? What is false acceptance rate? For our project, the false acceptance rate, let's say I am an imposter or a negative person, right? And if I'm using the system should detect that this is not Catherine, this is someone else, that's me, right? But the system still allowed me to use your system. That means it's false accepting the imposters, right? That the rate of that, it's called false acceptance rate. What is false rejection rate? The false rejection rate is something, Catherine was the actual user, right? But our system thought, no, this is some imposter, this is not Catherine. And they rejected Catherine even though she was the actual user. So the rate of that is called false rejection rate. Now, in both the scenarios, false acceptance rate and false rejection rate, you do not want any of them to go higher, right? So EER is the equal error rate. So it makes sure that both of the rates are together or nearby on similar, right? So if it's 50-50 or 45-55, it's a good scenario for your model. So EER, equal error rate, works for that. From our model, this is the first scenario where we had one user trained and one user tested, right, on just one data set. You can see that we have got the average EERs, average FARs, and average FARs and average FRRs, in which random forest has worked better than other two of those in the first scenario. And I would just jump in over here for this one and I'll go back. And in the second scenario, you can see that k nearest neighbor has worked better. You can see that higher EER, that means your FAR and FRR rate is almost equal, right? If you can recall, in the first scenario, we had the highest accuracy of 94.4%, right? And in the second scenario, we had the highest accuracy of 99.2%. These are, again, some evaluation metrics and evaluation figures that machine learning people use to showcase their work. Over here, these curves are called the ROC curve. As we talked about AUC, right? Area under curve. We saw that in the table. The higher the AUC, the higher the performance of your model, right? Better the performance of your model. If you can see over here, ROC curve for KNN worked better for both of the scenarios, right? You can see the curves are almost nearby 10-1, right? In the corner. For this one, the curves are in the middle, and for this one, there are some curves nearby 1, but some curves nearby 0.8 to 0.9, right? So from this, you can clearly see that for KNN, the performance was 100 times better than both of these, right? So this is another way to show the performance of your model. Confusion matrix. The name is confusing, but not the matrix. So I can talk about that. You can see over here. Here you have the true label. Here you have the predicted label. Label in the sense of 3579. These are all the users listed here, and these are all the users listed here. So these are the actual users which we have fed to our model to figure out whether it's an imposter or an actual user, right? And these are the results of the predictions. You can see from the diagonal values over here that when I wanted to predict that it is user 16, right? For user 16, our model was able to figure out that for 228 times, it was user 16. What are the other values? For another time, when we actually fed user 16's data to our model to predict that whether it's user 16 or not, it predicted it's user 15, right? So other values shows the data of imposters, or I would say for false acceptance and rejection rates, right? But the values in the diagonal shows that our model was able to predict the user, that yes, it is the user that using the system. Similarly, for the second scenario, you can see that most of the AOC curve, right, it tends to between 0.8 to 1. And for this one, you can see some are nearby 1, but most of them are nearby from 0.7 to 0.85. But again, for KNN, you have most of them in the corner of 1, right? So that means your KNN algorithm, even for the scenario B, is working the best, having 99.2 accuracy, right? Which means the KNN algorithm was able to predict 99.2 times out of 100 that yes, it's a legit user, or no, it's an imposter. This is a similar scenario of the confusion matrices scenario A. This is another scenario I wanted to talk about. We have similar graphs for all algorithms, random forest, decision tree, and KNN. I have just one algorithm over here. As I said, that we are focusing on 3 important mouse movement and mouse dynamic events: mouse movement, press and click, and drag and drop, right? You can see we did separate testing and training for each of the events, also using the classifiers. I have just information over here for the random forest. You can see these are the similar ROC curve that we have seen before. Now we have the ROC curve separately for these actions, right? In going in detail, you can see the AUC that we have got using random forest, the better was 92.6%. I can tell you that for KNN, which has worked the best for our project, right, has an average AUC of 99.5%, which has worked the better. But having a small amount of time, I didn't include all of the images over here. This is just an example of how the data would look like when we have collected the data. You can see the time step, event ID, event name, X and Y. As I've said, there are 6 events, right? Left click, right click, scroll up, down, mouse movement or not, and the event type. So that was our project. We collected the data, we developed our own model, and we got good accuracies compared to what we saw before, right, using the machine learning models. Now another thing came in my mind while working on this project, right? Most of us are using the cell phones these days, or tablets, or laptops, or any other touchscreen, I would say, devices for authenticating yourself or using for your systems, right? Now, if you're not using mouse, then how your system will be able to continuously authenticate using that, right? So our next future or ongoing project is on this for touch thing. So in that, I can just give you an example. Let's imagine this screen is touched, right? When I'm touching the screen, it will give me the coordinates of X and Y. It will give me the length of my thumb or finger I'm using to touch my cell phone or my tablet, right? It will give me the pressure. Like I might be giving more pressure while typing. Some of you might not be giving more pressure, right? And similarly, so all of these features are undergoing right now to be collected for our next project, and we'll be working on the continuous authentication using the touch dynamics. Contribution of this work, you can see that we covered that the highest accuracy that we have seen till now was 87.6%, right, from the previous user, but we were able to get better than that using all of our 3 algorithms. We achieved the higher accuracy of that. We developed a tool and a new data set, right, to collect that. We collected the data for the Minecraft. Right now there's data collection going on for the Fruit Ninja, for Snake.io, for piano tiles, and many more, for the cell phones and the desktops. For the new collection features, as I've said, it needs to go to the IRB. We're working on that right now. Extract the features for the new mouse movement data and the data collected by the cell phones and touchscreens, and comparison of deep learning and machine learning. So now we are working on deep learning algorithms to go for the mouse movements and the touch dynamics. And then we'll compare what results we have achieved right now from machine learning and what results we are going to achieve from deep learning, right? From this project till now, we have published 4 papers. I would say 3 conference papers and a journal paper. First, we published a paper at Springer Nature in the International ICCT 2021 conference in February. We published a journal paper into very prestigious 3.7 impact factor journal MDPI Information in the summer. And we just got accepted for these 2 papers, I believe. Yeah, these 2 papers in IEEE conference ICET 2021 for this project, which will be in later November this month. And in the conclusion, I want to say that what we hypothesized in the beginning, we were able to get higher accuracies compared to the existing literature. We were able to develop a model using machine learning to detect the imposter and to authenticate a user in a continuous manner, right? The model is able to protect users' information, and the model was also able to lock the system. I didn't have the screenshot of that because of amount of time, but model was able to lock the system, which was our main hypothesis too. In the authentication phase, if you can remember, The scenario 1, where we trained the users on one data set and tested in one data set, we got the highest accuracy of almost 94%, right? And in the second scenario, where we trained all the users together and tested all the users together on the same data set, we got even more higher accuracy of, it says 100%, but I remember it's 99.2%, right? Almost you can say 100%. So I believe right now the result says training all the users together and testing all the users together gives higher accuracies. We might come up with the next solution of that, because we also want to make sure that the person who's trained single on data set and tested on the single data set should also get higher accuracies. So I believe our current work and the future might take care of that. So that's my project. Thank you so much for listening to me. If you're interested in collaborating with the research with the aims, just send me an email and I can give you more information on that. All right? Thank you. Any questions?
Just to remind our speaker, it's 12:50, just to watch out for time.
Sure.
If there are questions.
I can take your questions from in person quickly. Yes.
So I'm trying to figure out how to word this most coherently. What about people? How would the system account for people who don't really have a coherent pattern, or does everyone have a specific pattern that they use things in?
Yes, so the question is about how a system will be able to figure out that that is a coherent pattern, that yes, this is the pattern of the user, right? That's why that machine learning comes in the picture, that before you give the system that right, that okay, now you have the right to figure out whether I'm a legit user or the imposter, right? Your patterns will be stored in the system and the model will be trained on that. It wouldn't be just 1 or 2 sessions, it will be longer time. So based on that, obviously the system will be able to figure out that yes, it's you and it's not the imposter.
And one other question along those lines, how would it factor in letting someone else use your computer, for example?
Okay, the question is, what if I allow other person to use my computer, right? I believe that's a good question. We are working on that problem of that. As an example, if I want someone else to use my system, right, we will have another view. As an example, in Canvas, if you can see, we have for faculty's student view, right? So faculties can go for the student view without harming the student's information, right? So similar to that, we can have an access or another button over there for the system for any of those using our model, right? They can go for that personal view in which they can use their credentials to log in and to complete all the process they want to, right? And they cannot harm the information or the model that's trained for the actual user.
But what if you want someone to log into your account, say if you're a student and you need your parents to complete a few things?
I believe then it needs to go to the person to sit next to them. Otherwise, there is no other way to solve that. Because you yourself is giving authority to use other person, then it shouldn't be an issue when it comes to the information bridge. What the problem looks like without your permission, when other people tries to steal your data, that's what we're working on. But if you give your permission that, yes, this is my system, please use it, then I believe it's your fault. You shouldn't do that.
I'll ask my question after. That's okay.
Well, thank you, everybody. I think, maybe if there are other discussions, we can take it offline as well.
Yep, you can send me email, or you can send the email to ORSP, and they can forward it to me. I can give you answers on that.
Right.
But yep, thank you so much for listening to me, and thank you so much for the opportunity, Catherine.
Well, thank you very much for
Yep.
coming.
Thank you.